Part 2, scientific notation. Now, you have to be able to manipulate these numbers that we're going to be expressing in scientific notation, and this is what becomes a problem area for a lot of folks. We have to be able to manipulate decimal points left and right. We have to be able to manipulate exponents up and down. So on page 11, we're on page 11 now, you'll see there's two block letters, a block letter L and a block letter R. Okay, what I want you to do is put an arrow right here on this L, just like that, and put an arrow on the R, just like that. That's going to keep you out of hot water. We need to be able to convert numbers back and forth from standard notation to scientific notation and back. All right, so starting here on the first line, converting numbers in standard notation to scientific notation. That means that you're going to move the decimal left or right. So if the decimal point moves to the left, then the exponent's going to go up. If the decimal point is moved to the right, then the exponent's going to go down. It's as simple as that. Converting numbers in scientific notation back to standard notation. In this case, you're going to probably manipulate the exponents first. So again, if the exponent moves up, then the decimal point is going to move left. If the exponent moves down, then the decimal point is going to move to the right. Cheetah rule for standard notation. Any number in standard notation, and remember that's just plain old numbers, any number in standard notation can be expressed as itself times 10 to the 0. Remember, 10 to the 0 equals 1. So if you got a number in standard notation, you want to dress it up, just slap a 10 to the 0 on it. There you go. General rule for correct scientific notation. You want to have only one digit in the coefficient to the left of the decimal. Only one digit in the coefficient to the left of the decimal. Now, that's knife and fork school drinking tea with your pinky out type scientific notation. And that's why we have this very important exception. It is often more convenient to ignore this rule during actual calculations. In other words, don't get hung up on this and create more problems than necessary. As you're working through a problem and you have 3 or 4 or 5 digits to the left of the decimal and you still have calculations left to go, just leave it like that and wait until you get to your final answer to put it in proper scientific notation. So let's try a few of these. Example 1, 873.463. All right, there's my number in standard notation. I'm going to change it to scientific notation. And just so I have a reference point, I'm going to slap a 10 to the 0 on it, just like that. Now, I want the coefficient to read like so. 8.73463. To do that, I moved my decimal 2 places to the left. That means my exponent's going to go up 2 places to make it 10 to the 2nd power. Next example, 0.00785. All right, there's my number in standard notation. And just so I have a reference, I'll put 10 to the 0 on it. I want my coefficient to look like this. 7.85. And to do that, I had to go 1, 2, 3 places to the right. So I start at 0, and I'm going to go down 3 places. Just think of a thermometer. 10 to the negative 3. Third example. This is something fairly typical as you're working through a problem. You wind up with an answer that reads like this, 56.98 times 10 to the 5th. Now I want my coefficient to read like so, 5.698, and I went one place to the left. That means my exponent is going to go up one place. That's going to make it 10 to the 6th. It's as simple as that. Now, the next page, page 12, is stuff for you to try out, and we'll go over the answers at the end of this lecture. All right. Now on page 13, you see some lab exercises. Convert to scientific notation 5,280 feet. And then the next page, page 14, shows you the answers and the how-to. Page 15, more lab exercises. 5.678 times 10 to the 0. And page 16, there's the answers. And then we get to page 17, operations in scientific notation. You have to be able to do adding, subtracting, multiplying, dividing, squares and square rooters, cubes and cube rooters. So we're going to take a few minutes and go over that. So we're on page 17 now. Okay, page 17, operations in scientific notation. We'll start with multiplication. So here we go, fill in the blanks. The critical rules: multiply the coefficient, retain the bases, and add the exponents. So there it is. Multiply the coefficients, retain the bases, add the exponents, and recall, just in case you're rusty, adding a negative number is the same as subtracting a positive number. And we'll try this first example. 4.75 times 10 to the third. Now, we have 4.75 times 10 to the third times 2.43 times 10 to the 7th. And chances are really good that in high school, when you encountered a problem like this, they handed you a calculator and said, go ahead, mash the buttons, have a nice life. Well, okay, that's great. But we're going to do it a little bit differently here. We're going to write this stuff down. The thing about science is this. It shares something in common with the medical profession, with law enforcement and first responders and the military. We have all of these professions have one thing in common, and it's this: if it ain't on paper, it didn't happen. So we are going to write everything down. Furthermore, here's the other thing that you need to know. Here's a little bit of trivia. When you're doing a math problem and all you're doing is mashing a button, and then they've done studies on this, there's a certain portion of your brain that lights up. If, on the other hand, you actually write it down, it's an entirely different portion of your brain that lights up. And it's the portion that's more associated with doing mathematics anyway. The point is, if you write it down, you're going to be engaged with the problem. And when you make mistakes, you're going to catch them a lot sooner, and you probably make fewer mistakes anyway. Anyway, so let's move on. We're going to do 4.75 times 10 to the third. Times 2.43 times 10 to the 7th. I'm going to stack them, and I'm going to split them just like that. Now this part we'll use the calculator for, and you should get 11.543 times 10 to the 10th. And if we put it in proper form, we'll make that 1.154. Now I went to the left, times 10 to the 11th. Now, I'm aware that some of you have calculators that will do the whole shebang for you, including scientific notation, adding and subtracting the exponents. I'm going to caution you right now, don't do that. Avoid that feature, because it's the road to perdition. Here's why. It depends on what kind of a calculator you got, whether it's a Texas Instrument or a Casio or some off-brand that you picked up at a flea market, who knows. The point is they all have different algorithms, and what is eventually going to happen, and inevitably going to happen, is your answer is going to be off by one exponent. And you might say, well, that's pretty close. Well, no, it's not. It means that your answer is either 10 times too big or 10 times too small. And that can be a real problem. So use your calculator for this part. That makes sense, of course. Use your gray matter for adding your exponents. And guys, let's be honest. If you really need a calculator to add 3 plus 7, then you got bigger problems than anything we're going to be able to address in this course anyway. All right? So yeah, gray matter here, calculator there, and you will make fewer mistakes. Moving on. 3.72 times 10 to the 7th. Times 1.67 times 10 to the negative 2. Stack them, split them. Go ahead and button those out on a calculator. You should get 6.212 times 10 to the 5th. Remember, adding a negative is the same as subtracting a positive. All right, so that's for multiplication. Next is division. Okay, division critical rules. Divide the coefficients, retain the base, and subtract the exponent. Divide the coefficients, retain the base, subtract the exponents, and recall that subtracting a negative number is the same as adding a positive number. All right, so here's our first example. 9.35 times 10 to the 8th divided by 3.54 times 10 to the 4th. So 9.35 times 10 to the 8th over 3.54 times 10 to the 4th. Okay, stack them, split them. Use a calculator for this. You should get 2.621. And, no, I take that back. .641. 2.641. Okay, I read that wrong. Times 10 to the 4th. All right. Next example. 8.62 times 10 to the 6th. Over 3.97 times 10 to the negative 3. Stack them, split them. Calculator for that. You should get 2.171 times, subtracting a negative, same as adding a positive, 10 to the 9th. That's division critical rules. Next page, page 19. Adding and subtracting. Now, believe it or not, adding and subtracting can have some extra steps thrown in. So first, the critical rules. Exponents must match. add or subtract the coefficients, retain the bases, leave them alone, and retain the exponents, leave them alone. So for the first example, we got 6.72 times 10 to the third plus 2.97 times 10 to the third. The exponents match. We're ready to go ahead. So 6.72 times 10 to the third plus 2.97 times 10 to the third. Stack them, split them, add them up. You should get 9.69 times 10 to the third. Right? Pretty straightforward. Now look at this next one. We have 9.56 times 10 to the fifth minus 8.47 times 10 to the fourth. The exponents don't match. So how do we get out of this one? Well, the answer is we cheat. So let me show you how to cheat. Watch how I write this out. 9.56 times 10 to the fifth. See how I'm spreading that out? Minus 8.47 times 10 to the fourth. Stack them, split them. Now, I spread those out so I could give myself a little room. Now, here's where the cheat comes in. I'm going to change 10 to the fourth to 10 to the fifth so that they match. Now, my exponent went up, which means my decimal point is going to move to the left. And so now, that 8.47 becomes 0.847. And now everything matches. I can go ahead and complete the problem, and you should get 8.713 times 10 to the fifth. Now some folks ask, could I have just changed the 10 to the fifth to the 10 to the fourth instead? Yeah, you could do that too. Many roads lead to Rome. Either way it'll work. All right, so that's adding and subtracting. Next page, page 20. We got to be able to square and cube numbers. So how do we do this? Well, here we go. Critical rules. You square or cube the coefficient, depending. You retain the bases, and you multiply the exponent by 2 or 3. And recall that multiplying unlike signs results in a negative, multiplying like signs results in a positive. So once again, we square or cube the coefficient, retain the bases, multiply the exponent by 2 or 3 depending, and recall that multiplying unlike signs results in a negative, multiplying like signs results in a positive. So here we go. Here's our first example. 2.56 times 10 to the third, all squared. So, we're going to square that coefficient, and you should get 6.554. And I'm going to multiply the exponents to make it 10 to the 6th. Now, let me pause and explain this one a little bit because this does tend to throw some people. And again, this goes back to how we define an exponent. Remember, an exponent is an instruction. This exponent here is telling me to write this number down twice and multiply them. Stack them, split them. Well, we already know what that equals. 6.554. And what do we do here? Well, we add the exponents, 10 to the 6th. Okay, so be aware of that one. That one will bite you. Okay, when you got exponents on either side like this, you're going to multiply them. Okay, next example. Example 2. 2.56 times 10 to the third cubed. All right, so if we cube that number, you should get 16.777 times 10 to the 3 times 3, 10 to the 9th. And to put it in proper form, I'm going to make that 1.67, and we'll round it to the 8th, times 10. I went to the left, so it's going to go up 10 to the 10th. Example 3. 3.12 times 10 to the negative 6, all squared. Square the 3.12, you should get 9.734 times 10 to the negative 12. And example number 4. 3.12 times 10 to the negative 6, all cubed. So 3.12 cubed comes out to 30.371 times 10 to the negative 18. I'm going to make that 3.037. I move to the left, which means my decimal goes up. Think of a thermometer. I'm 18 below 0. I'm going to go up 1 degree. That's going to make it 10 to the negative 17. There we are. Square roots and cube roots. This is page 21. These are all operations you're going to need to be able to do in this course. Okay, critical rules for square roots and cube roots. And we're going to cheat a little bit on this one. Exponents must be divisible by 2 or 3, depending. If you're going to do a square root, the exponent has to be divisible by 2. If you're going to do a cube root, it's going to be divisible by 3. Assuming that they are, then you're going to square or cube root the coefficient, you're going to retain the bases, and you're going to divide the exponents by 2 or 3. Divide them by 2 or 3. And recall that dividing unlike signs results in a negative, dividing like signs results in a positive. So let's look at this first one here. Square root of 9.46 times 10 to the 6. It's a square root. The exponent is even. We're good to go. So it's pretty straightforward. 9.46 times 10 to the 6. Okay. And just to remind you, with a square root, even though you don't see them there, that little 2 is right there. That's the 2 that we're going to divide by. Okay. So, using the square root function on your calculator, square root of 9.46 comes out to 3.075 times 10 to the 6 divided by 2, third. Okay. Now let me just pause here and explain why this works the way it does. Let's just think about this. When you are saying square root, what you're really doing is you're asking a question. The question is, what number times itself will give me this number? That's the question of a square root. So if I did, for instance, the square root of x to the 6th power, I'm saying what number times itself will give me x to the 6th power, and that number is x to the 3rd power, because x to the 3rd times x to the 3rd equals x to the 3rd squared, yeah? And x to the 3rd times x to the 3rd equals x to the 6th. Okay, that's the rationale behind it. Okay. Okay, the next example is supposed to be example 2. It still says example 1. So yeah, that's a typo, and I didn't have an editor, so that's my excuse, and I'm sticking to it. So now let's do the cube root of 9.46 times 10 to the 6th. Okay. My exponent is divisible by 3, so I'm good to go. The cube root of 9.46 is 2.115. 6 divided by 3, 10 squared. That's when everything works nice and neat. Let's look at these next two examples, example 3 and 4, where it doesn't come out nice and neat, and we're going to have to cheat. I'll show you how to cheat. My background is naval aviation, and we have a saying in naval aviation: if you ain't cheating, you ain't trying. So let me show you how to cheat. So let's take this first one here, square root of 8.1 times 10 to the 5th. All right, so I've got an odd numbered exponent. What do I do now? So what I'm going to do is I'm going to cheat by dropping this power of 10 down to 10 to the 4th. So my exponent went down, which means my decimal point goes to the right. And now that makes it 81 times 10 to the 4th. Good to go. Square root of 81 is 9 even. 4 divided by 2, 2. Now I want to show you something here that's going to have relevance down the road. What would happen if we didn't cheat? How would this get managed? Well, let's do this one just so you can see a comparison. So we'll start with our original problem. We've got 8.1 times 10 to the 5th. I'm going to leave it just like that. So the first thing I'll do is I'll do the square root of 8.1, and that should get me 2.846. Now I've got this problem here. What do I do with the exponent? Well, I still divide it by 2. That's another way of saying this. Five over 2 equals 2.5. Now I'm going to step off camera for a second and grab a calculator. So, there is a function on your calculator whereby you can do 10 to the 2.5. And that equals 316.228. And now I'll multiply that times 2.846, and I get 899.984. And that's just a matter of rounding the decimals. But 9 times 10 squared equals 900 even. And so we can see, yeah, that's pretty close. All right. So we will be using this type of a decimal, a fractional, or this type of an exponent rather. We will be getting into fractional exponents down the road when we get into logarithms. Don't panic. We're not there yet. And once we do get used to it, you'll find that it's actually a lot easier than it seems. But that's for way down the road. For the time being, it's just as easy to go ahead and cheat, and yeah, we can get away with that. So continuing on, last example. Cube root of 8.1 times 10 to the 5th. All right. So I'm going to cheat on this one. I'm going to make that cube root up. I'm going to drop 10 to the 5th down to 10 to the 3rd. That's certainly divisible by 3. So my exponent went down 2 places, which means that my decimal moves over to the right 2 places. That makes it 810. And the cube root of 810 is 9.32. And 3 divided by 3 is 1. 10 to the 1st power. So there you go. Now on page 22, there are some examples for you to play with. Page 23 has the answers. Page 24, some more examples. And page 25, the answers that go with them. Now I promised that I would go over the exercises, the lab exercises that are on page 12, so let's take a minute and do that. So we're going to convert these numbers, this first batch of numbers, into correct scientific notation. The first one is 186,000. That gets converted to 1.86 times 10 to the 5th. The next one is 0.0045. So we're going to convert that to 4.5 times 10 to the negative 3. 5,280 gets converted to 5.28 times 10 to the 3rd. 34.78 times 10 to the 3rd gets converted to 3.478 times 10 to the 4th. 783.487 times 10 to the negative 8 gets converted to 7.83487 times 10 to the negative 6. The decimal went to the left, so the exponent goes up. Think of a thermometer, 8 below 0, goes up 2 degrees, now it's 6 below 0. Okay. 2.85, we can just do this, 2.85 times 10 to the 0. The next one is 0.000859 times 10 to the negative 9. That converts to 8.59 times 10 to the negative 13. The next one is 0.0835 times 10 to the 6, converts to 8.35 times 10 to the 4th. Next one is 0.000386 times 10 to the 12th. That's a lot of zeros. That becomes 3.86 times 10 to the 7th. 73.96 converts to 7.396 times 10 to the 1st power. 1/4, I kind of threw that one at you as a little bit of a curveball. 1/4 equals 0.25. I'll slap a 10 to the 0 on that. Now we'll make it 2.5 times 10 to the negative 1. And the last one in this sequence is 0.937. 0.937 converts to 9.37 times 10 to the negative 1. Then we have some numbers to convert into standard notation. The first one is 1.36 times 10 to the 3rd. That converts to 1,630. 3.637 times 10 to the negative 1 converts to 0.3637. 2.94 times 10 to the negative 6 converts to 0.0000294. 36.345 times 10 to the negative 2 converts to 3,634.5. All right, so there's your lab exercises. Now, if you noticed that the camera was shaking a little bit, that's because Mr. Smudge decided to pay a visit and help along with the lesson. So meet Mr. Smudge. He's an astronomy cat. All right, so that takes care of this part.